Here is one period of a sine wave. It's the whole shebang before the pattern starts over again. So what we're going to do is we're going to find these 5 coordinates because these 5 coordinates give enough information that I can sketch out the rest of it and connect the dots. When x gets a new coefficient, then what you're going to do is take all of your x values and divide them by that new coefficient. Now this is going to feel a little counterintuitive because aren't we multiplying by something? Shouldn't that make it bigger? In this case, we're multiplying x by 2. Shouldn't that make it bigger? Well, actually what's happening is I'm going to take this whole thing and I'm going to horizontally compress it. X ends up being twice as powerful, so it only has to go half as far to get the same results. Now what that's going to look like is you're going to find your 5 coordinates right here. You're going to take all of your x values, divide them by your coefficient, in this case 2. And when you divide all of your x values by 2, then you can fill in the rest of the sine wave. Those 5 coordinates are going to be our anchors. Likewise, when your x is multiplied by a number smaller than 1, like a half, then x is going to be half as powerful, so it has to go twice as far to have the same result. That's why you're going to take all of your x values and divide them by half or multiply them by 2, which is the same thing. Now here's the period of a cosine, and it has the same 5x values, it just has different y values because it's a cosine. Now if I want to go from y equals the cosine of x to y equals 1/3 the cosine of x, that means that I have to divide all of my x values by 1/3 or multiply all of my x values by 3, and then that thing horizontally stretches to this. So the horizontal shifts require a little bit more of a visual cue. What I want to point out is when the c value moves to the right, then the graph moves to the left. When the c value moves to the left, then the graph moves to the right. And what you should get from that is whenever you see x plus something, you should subtract that something from all of your x values. And when you see x minus something, you should add that to all of your x values. It feels counterintuitive, but x typically feels counterintuitive. So here's y equals cosine of x, but we want y equals cosine of x plus 3 pi over 4. So I want you to imagine taking this period of the cosine graph and sliding it over here. And the way we're going to implement that is you're going to find your 5 points, and then you're going to subtract 3 pi over 4 from each of them so that they all go over here, and that's when you can go fill in the rest of that period. Now amplitude, because of its position, is going to affect the y. So that is why everything is going to feel a little bit more normal. When something gets bigger, it gets bigger. When something gets smaller, it gets smaller. Y does exactly what you think it's going to do. X is the one that's always feeling counterintuitive. So if I make A bigger, it's going to make all my Y values bigger. And when I make this smaller, it's going to make all my Y values smaller. The other fun thing is that I can go negative with this. That's exactly what you think it's going to do. It's your amplitude. To go from y equals the sine of x to y equals 5 times the sine of x, you're going to get your 5 points. You're going to multiply all of your y values this time by 5, and then you're going to connect the dots. A note about tangent. It has a different period. Sine and cosine have a period of 2 pi because it takes that long to get all the way through one cycle and the pattern repeats. But tangent has a period of just pi from negative pi over 2 to pi over 2. So We're going to change our period for that. And these would be the x values that I might choose for anchor points for a tangent. And also, negative 1.732 is approximately the square root, negative square root of 3. So this is what it looks like for me to move around the coefficient of x. Horizontal stretch and compression. And this is what it looks like to add or subtract something to x. This is your horizontal shift. And this is what it looks like to change the amplitude or the number that you're multiplying in front of the trigonometric function. Sometimes it can be negative, it can be positive. So that's what all these things do.